All right, let's dive in. Today, we're going to master one of the most important shapes in all of math, the triangle. You see them everywhere, but they're also the secret building blocks of geometry. And understanding them unlocks, well, pretty much everything.
Now you might be thinking, triangles, really? But yeah, really. From those massive bridges that seem to defy gravity to the GPS in your phone that tells you exactly where you are, the engineering and tech behind them rely on the simple, rock-solid logic of triangles. And the key to that logic is a concept called congruence.
So, here's our game plan for this explainer. First, we'll nail down what congruence actually is. Then, we'll get into the 4 essential rules that are your secret weapons for solving problems. After that, we'll see how these rules help us discover other cool properties of triangles. And finally, we'll wrap it all up with a cheat sheet to get you ready for any test.
So, let's get right to it. What in the world does it mean for two triangles to be congruent? Well, the easiest way to think about it is like they're identical twins. They're not just kinda similar, they are perfect, exact copies of each other. Same shape, and crucially, the exact same size.
So here's the official textbook definition. For triangles, it means that all their matching parts, that's all 3 sides and all 3 angles, are exactly equal. That's 6 different things that have to line up perfectly.
But wait a second. Do we really have to check all 6 of those things every single time? That sounds like a lot of work, right? Well, good news. The answer is no. Mathematicians have figured out some amazing shortcuts, and these are the congruence rules. Honestly, these are going to be your best friends.
There are 4 of these main rules. Think of each one like a different key. Depending on what information you're given in a problem, you'll pick the right key to unlock the proof. Let's get into the first one. Our first rule is side angle side, or just SAS. The best way to remember this one is to think of the angle being sandwiched right between the 2 sides. The letters literally tell you the order: side, then angle, then side. Now, check out that word on the slide, included. This is the most important part of this rule. It's not just any angle. The angle has to be the one formed by the 2 sides you know. If it's floating around somewhere else, SASS won't work. And listen up, because this is a huge exam alert. People mess this up all the time. If you're using SAS, you have to double check that the angle is between the 2 sides. If it's not, you can't use the rule. Simple as that.
Okay, on to our next key. Rule number 2 is angle side angle, or ASA. You can probably guess what the important condition is going to be here, right?
Yep, just like before, it's all about that word included. For ASI, the side you know must be the one connecting the 2 angles. You have an angle, then the side right next to it, and then the angle at the other end of that side.
The third rule is probably the most straightforward one of them all. Side, 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 or SSS. Nice and simple. No angles to worry about here at all. This one is exactly what it sounds like. If you can show that all 3 sides of one triangle are the exact same length as the corresponding 3 sides of another triangle, then boom, they have to be congruent. The angles will just magically be the same too.
And finally, we've got a special rule. This one only comes out to play for a very specific type of triangle, right-angled triangles. It's called the right angle hypotenuse side rule, or RHS.
So for this one, you need a specific 3-part recipe. First, both triangles must have a right angle. That's the R. Second, their longest side, the hypotenuse, must be equal. That's the H. And third, one of the other 2 sides has to be equal. That's the S.
And here's another huge exam alert. Do not forget this. To use RHS, you absolutely need all 3 of those pieces. You have to know it's a right angle. You have to know the hypotenuses are equal, and you have to know one other pair of sides is equal. Miss any one of those, and you can't use the rule.
Okay, so now we've got our 4 powerful rules. Let's put them to work and see how they help us figure out other cool stuff, like the special properties of isosceles triangles. Those are the ones with 2 equal sides.
This is so cool because it shows how elegant geometry can be. It's basically a 2-way street. The first theorem says if you have 2 equal sides, then the angles across from them have to be equal. And the converse is also true. If you have 2 equal angles, then the sides across from them have to be equal. They're linked.
Next up, let's talk about the fundamental laws of triangle physics, you could say. You can't just take any 3 random lines and make a triangle. There are rules for what's actually possible.
And there are 2 big ones you need to know. The first is super intuitive. The biggest side is always opposite the biggest angle. Makes sense, right? The second rule is like a reality check. If you take any two sides, their lengths added together must be greater than the third side. If not, they literally won't be long enough to connect and form a triangle.
All right, time to put all this together and solve a classic proof. So here's the setup. You've got this triangle, ABC, and there's a point D on the bottom side, BC. The only clue you're given is that the line AD has the same length as the line AC. Your mission is to prove that side AB is longer than side AD. So, where do we even start?
Let's walk through the logic detective style. Step 1, zoom in on that smaller triangle ADC. We're told AD equals AC. From our isosceles rule, we know the angles opposite those sides are equal. So angle ADC equals angle ACD. Got it. Step 2, angle ADC is also an exterior angle for the other triangle ABD. A really useful theorem says an exterior angle is always bigger than the interior opposite angles. So angle ADC has to be bigger than angle ABC. Now we connect the dots. Since ADC equals ACD, we can just swap them. That means angle ACD is also bigger than angle ABC. Almost there. Now look at the whole big triangle ABC. We just proved that one of its angles, ACD, is bigger than another, ABC. And what did our inequality rules say? The side opposite the bigger angle is longer? So the side opposite angle ACD, which is AB, has to be longer than the side opposite angle ABC, which is AC. And since we were told AC equals AD, we did it. AB is greater than AD.
And there it is. How cool is that? You see how we just stacked the rules one on top of the other? It's like building with Legos. Each theorem clicks into place to build the final argument. Okay, I know that was a lot to take in. So let's boil it all down into one ultimate cheat sheet. This is everything you need for that last-minute review before an exam.
Here they are, the 8 most important tools in your toolkit. The 4 congruence rules, SAS, ASA, SSS, and the special one, RHS. The 2 isosceles triangle rules, which are 2 sides of the same coin. And the 2 inequality rules that tell you what's possible. Go ahead and pause here, take a screenshot, do whatever you need to do. Get these locked in.
All right, knowing the rules is half the battle. Now you've got to use them. It's time to enter challenge mode and put your knowledge to the test. Let's see how you do.
Let's start with a gentle warm-up. These are the easy questions to get your brain firing on all cylinders. I'll read them out. You pause and try to solve them. Ready?
For a question like number 4, remember that inequality rule. Let's check. Is 2 plus 3 greater than 6? Nope. So, there's your answer. How did you do? Hopefully that felt pretty good. Now let's ramp it up a notch.
All right, here come the medium questions. These might require a couple of steps or using 2 rules together. Take your time and think them through.
These are designed to really test your application skills. A question like number 5 is a classic. You'll need to draw it out and then probably use SAS or RHS to prove 2 little triangles are congruent. If you're solving these, you are in great shape. Ready for the final boss?
Okay, this is it, the final challenge. These difficult questions are designed to really stretch your brain. Don't be discouraged if they seem tough. They're supposed to be. Just give them your best shot. Seriously, fantastic job for even attempting these. These kinds of problems are where you go from just knowing the material to truly understanding it. If you got stuck, that's totally okay. That's how learning works. Just go back to the cheat sheet and see which tool might have helped.
And that's a wrap. You have just gone through the entire blueprint for triangles. But you've done more than just learn some geometry rules. Every time you solve a proof, you're training your brain to think logically, to use evidence, and to build a solid argument. That's a superpower that will help you everywhere in life.
So remember, keep practicing and stay curious. Every problem is just a puzzle waiting for a solution. You've got the tools now, go build your future.